we were hired to perform a boundary survey for a heavy industrial facility in Central California a few weeks ago. And it's a multi-million-dollar facility, so it's not like a mini storage. This is a fairly complicated heavy industrial facility, like an oil refinery, similar type of facility. And so we were hired to perform the boundary survey. We did that. And about a week after we finished the boundary survey, we got a phone call from the client. And the client, the construction manager for the client, asked if he could get a copy of our CAD file for the boundary survey that we sent. It was actually a land title survey that we did. And I told the client, I said, happy to give you the CAD file, but I need to know, how it's going to be used and who's going to use it. I need to sign a release of liability. So I said, what are you guys doing with the CAD file? And he said, well, our designer wants to lay out the site improvements, and they want to use your CAD file to do that. Now that immediately raised a couple of red flags for me. And so one red flag was this wasn't a super what we call constrained or constricted site, but it was cozy. They had a 25-foot building setback, and they had some areas where they had some unstable soils, and so they were really, there were some limitations on where they could put their facilities on this particular parcel, and I was worried that they were going to violate that setback or potentially encroach on a property boundary if they weren't careful. On this particular site, the boundaries weren't well marked. There weren't fences or walls or anything like that. It was a fairly rural site. So I asked the construction manager, I said, well, what kind of topo survey did you get? What kind of topographic survey is your designer using? And, when you got that topographic survey, what control did the surveyor use? Because I didn't tie any existing control when I was on the site. He didn't ask me to do that. And, it's important that we know that because we need to try and get these two surveys to fit together. And he told me, well, we didn't get a topographic survey. We hired a drafter to whip out our design, and he just used some Google Earth contours. So I said, and this is a site with, it's not super steep, but there's some terrain to it. There's some slope to it. So I said, all right, look, I said, this is a recipe for disaster. I said, I'm not going to give your drafter my CAD file, my boundary. I said, we have to make sure that whatever topographic survey you guys use to design your facility is tied together properly with my boundary survey so that you don't design physical improvements that violate the building setback or encroach on the property line. And so I said, let's get together and figure out how we're going to do that. So that story got me thinking about the topic that I want to cover in this video, which is you need to tie together your boundary survey to the topographic survey that you use to design your site. And the way you do that, the way land surveyors do that for you, is with good survey control, what we call survey control. So I want to answer these three questions. What is survey control? What are improvements? When I say the design of improvements, what am I talking about? And why does your topo survey need to be performed using the same survey control as your boundary survey? And I've got a little sketch we'll go over. I'll try and help explain that. Okay, so let me answer that first question. What is survey control? So survey control is a set of physical marks that we put into the ground as a land surveyor when we're going to perform a survey. It doesn't matter what kind, boundary survey, topo survey, hydrographic survey. Any type of survey, we've got some physical marks. They're reference marks that we put into the ground, and we assign coordinate values to those marks. Right? So if you're not familiar with that, what a coordinate value is, it's like, if you remember the game Battleship, it's like we assign a grid value, just like you do in Battleship, D4. We assign a value like that, it's called a coordinate value, to those physical marks. And then everything else we survey is surveyed in relation to those physical marks that we set. So that survey control is really important. Okay, so I mentioned in the beginning that you want to make sure that your topographic survey that's done to do the design of your improvements is tied to the same control as your boundary survey typically. So when I say design of improvements, what does that mean? That's anything you're going to build on the site, right, that's expensive and permanently affixed to the ground, right? So I'm not talking about teepees or tents or even portable storage containers, but I'm talking about parking lots, sidewalks, buildings, drainage, utilities, all that kind of stuff. The kind of stuff that civil engineers design. Okay, so when a civil engineer goes to, you tell a civil engineer, I want to put this industrial facility on this empty parcel, he's got to go in and design that, right? And he might be working with an architect and a mechanical engineer, other folks on the design team, but typically the civil's taking the lead there. And he's going to lay out your site based on the existing topography. So one of the first things a good civil engineer will do will tell you, I need a good topographic survey so I can figure out how I'm going to design this site, right? Design the improvements for your site. And then a really good civil engineer will also understand he probably needs to have a boundary survey as well. So you want that topographic survey, which is just a survey that shows the shape of the earth. You want that topographic survey tied to the same control as your boundary survey because you don't want your civil engineer to design improvements like an access road, for example, or a parking lot that aren't on your property, right? Or in an easement that you control, one of the two. Okay, so that's why your topographic survey needs to be tied together using the same control as your boundary survey. Now, I understand this concept's a little tough if you're not familiar with the surveying or civil engineering industry, so I drew a little sketch that will hopefully help explain it. Hopefully you guys can see this. And if I can remember, I'll try and scan this sketch and we'll link to it in the video. So, in this green outline here, I have the parcel of real property, okay, the real estate parcel. And then you can see at each of the corners, I've got a circle there where the property corner would be, okay? And hopefully they're marked by monuments, okay, that's always a good thing. Okay, then I have the survey control, which I represented here with these triangles that I've highlighted in orange. There's 4 of them. Okay, so we can imagine this is a public street, this is a public street. And so we've gone in, as a surveyor, I've gone in and I've set some control here adjacent to the parcel that's going to be developed. This is a vacant parcel in our example. Okay, and then with these orange lines right here, these are what we call the baselines or the vectors that I use to tie together these control points. So I know that the angles and the distances that tie these control points together. Okay, and then in blue here, you can see the design, this thin blue line, you can see the design, the proposed design for this site, right? So the client's going to put a building on right here, and then they're going to have a parking lot here with a couple driveways out onto the street. Okay, now, you can see in our example here that we've got the parking lot and the buildings pretty close to the parcel boundary. Okay, and that's not uncommon, especially in urban areas, right? This is what we call a constrained site. So the client wants to, he's going to develop as much of this parcel as he can, right? And that's usually, in most cases, what a developer's trying to do. So he's going to put the building and the parking lot as close to the property line as he can, right? He wants to utilize that space. Okay, so it becomes really important then that the building and the parking lot and the other improvements, utilities, sidewalks, drainage areas, things like that, are designed to fit onto this parcel, right? We don't want any of the improvements to end up past the green line or wherever the setback is if this has a building setback on it. Okay, so that's why you need to tie the 2 surveys together. So the way a surveyor does that, he sets these control points here that I've got in orange, and he or she determines the relationship between them, which would be these orange lines here. Okay, and then what we do from those same control points, we tie out to some property corners here. You can see I put those vectors or those tie lines in green, right? So from the control point, we measure the property corners. Okay, and then from those same control points, you can see in these blue lines, we measure out 2 points that we collect as part of our topographic survey, right? We're trying to determine what's on this vacant parcel, what the slope is of the terrain, is there trees, is there existing utilities, what's on there. Okay, so that's in these blue lines. Okay, that gets surveyed from the very same control points as the boundary. Okay, and then finally, so the engineer takes that topo survey, does their design, then finally, the other last important part is somebody has to lay these proposed improvements out on the ground so they can be built, right? We call that construction stakeout or construction surveying or layout. Okay, so it's also important for the very same reason that the proposed improvements get laid out from the same control that the boundary and topographic survey was done on. And you can see right here, I've got an example of that. I've got some kind of magenta or pink colored tie lines representing the layout of this part of the parking lot right here in this building corner. That all needs to be done from the same survey control, right? If you don't have the same survey control for those three different surveys, boundary, topographic, layout, or construction, stuff isn't going to land in the right spot. It's not going to, the physical improvements that are being built are not going to be built on the right property, potentially, right? That's a huge problem, right? So the lesson here, the main lesson is you want to work with a land surveyor that understands this whole process we've talked about, from topographic survey, boundary survey, to construction layout. You want to make sure that your surveyor establishes permanent high quality survey control, because you're gonna need that through the whole process. The whole process from boundary survey design to construction, you're gonna need good survey control like this. So this is not something you want to half bake or cut corners on, right? You want to make sure that your boundary survey and your topographic survey are tied together using the same good survey control, so that your civil engineer and the other members of the design team can design improvements that land on property you actually own and control.